Hi, welcome to the session 5 on the Core Java tutorial series. So today we'll be discussing on the various memory areas which is present inside the JVM. So basically JVM organizes its memory structure or divides its memory into 5 different subsections. So we have the method area, heap area, stack area, PC registers and native method stacks. And each of these subsections serves some different purpose. So today we'll be upon discussing on each of these memory areas in a much greater detail. From our previous sessions, we have a fair idea about the method area and heap area. So let's do a short recap of what we have actually learned about the method area and heap area in our previous sessions. So say for instance, we have a .java file, student.java present in our system. We need to execute this Java program, okay, in our system. So what is the first step we need to do? We need to convert this student.java file into bytecode because this bytecode is understandable to the JVM across all platforms. Okay, so the JVM may be installed in a Mac OS machine, maybe installed in a Linux machine, or maybe installed in a Windows machine. This bytecode is same for all machines. So this bytecode can be executed by JVM across all machines or in a cross-platform independent way, independently in cross-platform. Okay. So we have this student.class file now, which is compiled by the JavaC compiler and converted into bytecode, that is student.class file. So now to run this program, we need to execute the command Java followed by the class name. So our command will be Java student. What it does is it requests the compiler to load, sorry, it requests the JVM to load the student.class file into the memory area present inside the JVM. So to like work on anything, we need to store it in the memory. So what happens is the student.class file is a bytecode file, and this bytecode is loaded into the method area of the JVM in a binary format. This binary format information of the student.class file contains all set of exhaustive informations about the student.class file, such as the parent class name, uh, methods, identifiers, uh, member variables, member methods, etc. So all these sorts of information are present in a binary format in the method area on executing this Java student command. So this binary information is actually not useful for the programmer, right? Because the programmer will understand objects because this is an object oriented programming language. He or she won't understand what is the underlying information which is ciphered inside the binary format data, right? So what happens is simultaneously while loading this binary information in the method area, uh, a class file, class object of the student class is created inside the heap area of the JVM. This is a Java object and this is useful to the programmer. The programmer can extract all sort of exhaustive information about the class from this uh, student class. Okay, so this is all we actually touched upon in our previous sessions about the memory area. So today we'll be discussing on the method area in a greater detail. Okay, so let's get started. So here, as you can see in the screen, I have mentioned a few key points about the method area, and I'll be elaborating them in detail now. So the first point says that for every JVM, we have one method area. And the method area is basically created at the time of JVM start. So when do you think JVM starts up? Okay. So the answer to this lies in this diagram. Whenever we run the command Java student, it starts up the JVM. And while the JVM starts up, the various sections of the memories are allocated. So we have one section reserved for this method area, or this method area is created while the startup of the JVM or while we run the Java student command. So the first 2 points are, I guess, clear now. The JVM method area is one. For each JVM, there will be one method area. And this method area will be created at the very beginning or the while the JVM starts up. Okay. So moving on to the next point, inside of the method area, we have the class level static data, which is stored. So inside of the method area, we have all the class level static data, class level informations, etc., which is stored inside the method area. That is the exhaustive set of informations about the class. What is the parent class name? What is the method name? What are the various methods present inside the class, member methods, member variables, etc. Also about, and also the constant pools of a class will be stored inside the method area. Okay. Now, the method area is accessible by multiple threads at the same time. Since JVM has only one method area present inside it, so multiple threads can access the method area at a single time. Therefore, this method area is not thread safe. So, suppose this is our method area. This method area contains class level data, CL. I have represented it using CL. So this method area is accessible to multiple threads. Okay, it's accessible to multiple threads. Say, for instance, thread T1 wants to access the class level data, and simultaneously T2 wants to access the class level data or the static level informations which is stored inside this method area. Therefore, this method area is not thread safe. Okay. Now, another point about the method area is that the method area allocation might not be in a contiguous nature. Okay, the method area might not have a contiguous memory allocation. As we know in arrays, we have contiguous memory allocation. That is one block, one memory address. If we add some bytes to it, we'll move to the next memory address and so on. So this is known as contiguous memory allocation, which we see in case of array. That is, the memory blocks are in a contiguous fashion. If we want to define an array, say integer ARR equals to new in 10. So 10 blocks of integer on this subsequent blocks of integer from the memory area of our computer will be reserved for the array. So this is known as subsequent memory allocation. But in our case, for method area, we don't have subsequent memory allocation for method area or contiguous memory allocation for method area. So this is all about the method area.